Hello everyone, I am PM Chalapandi, Assistant Professor working in Engineering College. Few of my students have been asking me, so what do you mean by Eigen values and Eigen vectors exactly? So it is very simple to understand. So I let you know through an example what do you mean by Eigen values and Eigen vectors. Let us consider a matrix capital A is equal to 1, 4, 2, 3 and two vectors. The first vector is called x1 is equal to 1, 1 and there is another vector x2 is equal to 1, 2. We have two vectors, we have a matrix. Okay, now let us see what happened when this vector hits this matrix. Okay, this is case 1. This is case 1. So let us see what happened when this vector hits this matrix, that is A times x1, which is equal to 1, 4, 2, 3. And what is the given vector? It is 1, 1. Now take a multiplication with this matrix with this vector. Then what happened? First row with first column. Okay. 1 times 1 is 1. Plus 4 times 1 is 4. Now second row with first column, this is 2 plus 3. Now what is the answer? 5. This is 5. Okay, here 5 is common, so we can take outside. The 5 times 1, 1. This is case 1. Okay, now let us see what happened when this vector hits this matrix, that is case 2. That is case 2. Okay, now in case 2, A times x2 is equal to, what is A? Again it is 1, 4, 2, 3. And what is x2? That is our second vector. It is 1, 2. Now take a multiplication. First row with first column. Similarly, second row with first column. Then what happened? 1 times 1 is 1 plus 4 times 2 is 2. 8. So 1 plus 8. Second row with first column, it is 2 plus 6. Implies 9, 8. There is no common number, so we cannot take outside anything. Okay, that's all. This is the result when the given vector hits the given matrix. Let us see the result. That means when a vector hits a matrix, this result in a geometrical representation. Now this is figure 1 for case 2. Sorry, for case 1. Okay, figure 1. I am going to plot the given vector first in the graph. So what is the given vector? It is 1, 1. In x-axis 1 and y-axis it is 1. So in x-axis 1 and y-axis the meeting point is this one. So definitely this vector is going towards this. Clear? Now when this vector hits this matrix, what happened? We have got this result. Now just plot this resultant vector in the figure 1. Then what happened? It is 5 times 5. Clear? It is 5 times 5. So in x-axis it is 5 and y-axis it is 5. So this is the plotting point. So this vector is going towards this side. So remember, clear, make sure. So this is a vector for the given result, that is x1. When this x1 hits this matrix, this is our result vector. So this is ax1. Okay. Now we have another result in case 2. This is when x2 hits this vector, this matrix. What happened? In case 2 that we have. So now we are going to plot the points for case 2. First, plot the points for given vector x2. In x1 and y it is 2. So it is going to be somewhere here. Okay. Now okay. Now when this vector hits this matrix, then the resultant vector is 9, 8. So in x-axis it is 9 and y-axis it is 8. So it is going to be somewhere here. Clear? So this is x2, this is x2, this is ax2. Look at the geometrical representation in figure 1 as well as in figure 2. In figure 1, it is scaled. Scaled means it has enlarged. Okay, the given vector, when it hits the matrix, it has enlarged. The resultant vector is enlarged. So it is scaled. Look at in second geometrical representation. This is here. The resultant vector is scaled as well as rotated. So it is scaled and rotated clockwise. So scaled and rotated. Scaled and rotated. So here what I want to say about eigenvalues and eigenvector. When a vector hits a matrix, if we get a result only scaled, then the given vector is called eigenvalue, eigenvector. If we get scaled and rotation as the resultant vector, then it is not a eigenvector. Ax is equal to lambda x. This is the formula to calculate eigenvector. Now, in case 1, look at in case 1. Here we have eigenvector and this is scaling factor. Okay, this is called eigenvalue and this is called eigenvector. This is called eigenvalue and this is called eigenvector. Thus, when a vector hits a matrix, if we get the result only scaled, okay, as we have seen in figure 1, if we get only scaled, then it is called eigenvector. The scaling factor, that is 5, is eigenvalue. Otherwise, it is not an eigenvector, as we have seen in figure 2. Okay. Now I hope now everyone have got a clear picture about eigenvalues and eigenvectors. Thank you so much. We will meet in next class.